Hello students, today we will see the derivation of Lagrange's equation for non-conservative system from Hamilton's principle. So for non-conservative holonomic system, okay, we consider non-conservative forces Fi, let Fi be the non-conservative forces, and we know that the work done by the non-conservative force can be given as delta W equal to summation over I Fi into delta Ri, where delta Ri is the virtual displacement and summation over I for the system of particles. Okay, so this virtual displacement delta Ri can be written as del Ri by del Qk into delta Qk. So this the product of non-conservative forces Fi and del Ri by del Qk is nothing but the generalized force. So it can be written as Gk. So Fi into del Ri by del Qk can be written as Gk since Gk is the generalized force. So suppose this is equation number 1. Now we will take Hamilton's principle, that is extended Hamilton's principle. This is also called Hamilton's variational principle, extended Hamilton variation principle. Okay, so this delta of integral from t1 to t2 t plus w dt equal to 0. So this is extended Hamilton's variational principle. T is the kinetic energy, w is work done by the system of the particles. Okay, t1 and t2 initial and final time. This delta is variation. Okay, so now we will take this delta inside this integral. So we will get delta t plus delta w dt equal to 0. So this is the variation in kinetic energy and this is variation in work done. So we will separate these two terms. Okay, this integral is common for these two terms. So we will separate the integrals. So integral from t1 to t2 delta t into dt plus integral from t1 to t2 delta w dt equal to 0. Okay, now we know the delta w from equation number 1. So since delta w is summation over k gk into delta qk, so we will replace this delta w by this term from equation number 1. So we will get this equation number 2, summation over k gk into delta qk dt. So this is from equation number 1. So suppose this is equation number 2. Now we will solve the first term of this equation number 2. So consider the first term of equation number 2, that is integral from t1 to t2 delta t into dt is equal to integral from t1 to t2. Since kinetic energy is the function of generalized coordinate and generalized velocity, so this t is the function of qk and qk dot. Now we will solve this by chain rule, since this delta is differentiation in over kinetic energy and kinetic energy is the function of qk and qk dot. So we will solve this by chain rule. So by okay, how can we apply the chain rule? First we will partial differentiate t with respect to qk, okay, then into delta qk, plus we will partially differentiate this kinetic energy t with respect to qk dot into delta qk. So we will solve this by chain rule. So after applying chain rule we will get del t by del qk into delta qk plus del t by del qk dot into delta qk dot, and here since this k term is here, so this is applicable to the system of particles, hence we have applied summation over k here. Okay, now this qk dot is, we know this qk dot or dot. What do you mean by this dot? Dot is the time derivative in classical mechanics. So this qk dot can be written as dqk by dt. Okay, so in next step I will write this qk dot as dqk by dt. Okay, now we will separate these two terms since this integration and summation is common to both terms. So we will separate this. So integral from t1 to t2 summation over k del t by del qk into delta qk into dt plus some integral from t1 to t2 summation over k. Now the second term del t by del qk dot delta dqk by dt into dt. Okay, now this delta we can take that inside this differentiation. Before that we will take this summation outside, or we will take this delta inside this differentiation. Okay, so after taking delta inside this differentiation, okay, d by dt delta qk. Okay, first term as it is. Okay, we will take we brought this delta inside this differentiation, so d by dt delta qk. Now we will put this summation outside the integral. Okay, we'll bring this summation over k outside the integral in front. Okay, so in this term we brought this integral outside, we will brought this summation outside the integral. Okay, now inside the integral we can see two functions. One function is del t by del qk dot and another function is d by dt del delta qk. So this is the product of two functions here inside the integral. Suppose this is the first function and this is the second function, so it is the product of two functions. So we can apply the product rule of integration, and product rule of integration says that first term integration of second minus integral derivative of first term into integration of second. So we will apply the product rule of integration here in the second term on right hand side. So after applying product rule, okay, first term as it is, summation over k first term integral of second minus integral derivative of first term integral of second. Okay, now look at here, look at this term integral, and here is differentiation. This is integral and this is differentiation, and since integral and differentiations are inverse processes, so this integral and differentiation will be cancelled out. So only delta qk will remain over the limits t1 to t2. Here also this integral and differentiation are reverse processes, so this integral and differentiation will be cancelled out. So only delta qk will remain here. So we did not put the limit here in the integration, because since that is definite integral, so limit is only to the outside the integral. Here inside integral there is no limit. Okay, there are no limits. Okay, so now, so after this next step, so here is delta qk over the limits t1 to t2. Here integration and differentiation cancel out, so here is also delta qk, and we know that this delta qk, according to the variational principle, this delta qk over endpoints, okay, will be 0, vanish. So this delta qk must be 0 at the endpoints. Okay, so this term will be 0 here, so this term will be 0 here. So we are left with only first and third term on RHS. Okay, first and third term, and in the first term, first and third term, so this integral is common, summation is common, and delta qk dt, delta qk into dt are common, so they can be taken outside. Okay, so this summation over k integral from t1 to t2 is common, this delta qk and product of delta qk into dt is common. So inside the integral we are left with del t by del qk minus d by dt del t by del qk dot. Suppose this is the equation number 3. So we got the value of this term. Okay, we got the answer of this term, integral from t1 to dt delta t dt is this. So we will use equation number 3 into equation number 1, since equation number 2 is this. Okay, since equation number 2 is this, and we got the value or got the answer of this first term, so we will put the value of this first term from equation number 3 to equation number 1. So using equation number 3 into equation number 1, so we will get summation over k integral from t1 to t2 del t by del qk minus d by dt del t by del qk dot delta qk into dt plus integral from t1 to t2 summation over k gk delta qk into dt. So here is also integral and summation and delta qk dt are common terms, so they can be taken outside. So summation over k integral from t1 to t2 del t del qk minus d by dt del t by del qk dot plus here plus gk, so this is also common term, delta qk into dt. Now since delta qk are independent of each other, so its coefficient will be vanished, it means its coefficient will be 0. So the coefficient of delta qk is this bracket term. So since delta qk are independent of each other, hence its coefficient must be 0, so the bracket term will be 0. Now we will bring this gk to that side, left hand side, right hand side. So del t by del qk minus d by dt delta t by del qk dot equal to minus gk. So we will rearrange the two terms on left hand side. So this will keep in first position and this will come to second position. Okay, so minus d by dt del t by del qk dot plus del t by del qk equal to minus gk. Now we will take minus common, so minus d by dt del t by del qk dot minus, here minus taken common, so here is minus del t by del qk equal to minus gk, minus will cancel out. So we are left with this equation, d by dt del t by del qk dot minus del t by del qk equal to gk. So this is the general form, this is the general form of Lagrange's equation. So we have reached up to the general form of Lagrange's equation for non-conservative system. Okay, we have started from non-conservative forces. Okay, then we have used extended Hamilton's principle, and from that extended Hamilton's principle we have reached up to this Lagrange's equation for non-conservative system. So this is the required Lagrange's equation for non-conservative system that we have derived from Hamilton's principle. So thank you very much.